Hello guys and welcome to my channel. In this session, we want to talk about final technical process. Well, the final technical process is disposal process. And if you want to find out more about this process, then don't miss this training session. Let's get started and as always, have a good one. The purpose of the disposal process is to end the existence of a system element or system for a specified intended use, appropriately handle, replace, or retired elements, and to properly attend to identified critical disposal needs. The disposal process is concluded in accordance with applicable guidance, policy, regulations, and statutes throughout the system lifecycle. Disposal is a lifecycle support process because concurrent consideration of disposal during the development stage generates requirements and constraints that must be balanced with defined stakeholders' requirements and other design considerations. Further, environmental concerns drive the designer to consider reclaiming the materials or recycling them into new systems. This process can be applied for the incremental disposal requirements at any point in the life cycle. For example, prototypes that are not to be reused or evolved, waste materials during manufacturing, or parts that are replaced during maintenance. This slide is the IPO diagram for the disposal process. The disposal process includes any steps necessary to return the environments to an acceptable condition, handle all system elements and waste products in an environmentally sound manner in accordance with applicable legislation, organizational constraints, and stakeholder agreements, and document and retain records of disposal activities as required for monitoring by external oversight or regulatory agencies. In general, disposal process includes the following activities. Prepare for disposal. Review the retirement concept, may be called concept of disposal, including any hazardous materials and other environmental impacts to be encountered during disposal. Plan for disposal, including the development of the strategy. Impose associated constraints on the system requirements. Ensure that the necessary enabling systems, products, or services required for disposal are available when needed. The planning includes the identification of requirements and interfaces for the enablers. The acquisition of the enablers can be done through various ways, such as rental, procurement, development, reuse, and subcontracting. An enabler may be a complete enabling system developed as a separate project from the project of the system of interest. Identify elements that can be reused and that cannot be reused. Methods need to be implemented to prevent hazardous materials from reuse in the supply chain. Specify containment facilities, storage locations, inspection criteria, and storage periods if the system is to be stored. Perform disposal. Decommission the system elements to be terminated. Disassemble the elements for ease of handling, include identification and processing of reusable elements. Extract all elements and waste materials that are no longer needed. This includes removing materials from storage sites, consigning the elements and waste products for destruction or permanent storage, and ensuring that the waste products cannot get back into the supply chain. Dispose of deactivated system element per disposal procedure. Remove affected staff and capture the tacit knowledge for future needs. Finalize the disposal. Confirm no adverse effects from the disposal activities and return the environment to its original state. Maintain documentation of all disposal activities and residual hazards. The project team conducts analysis to develop solutions for ultimate disposition of the system, constituent elements, and waste products based on evaluation of alternative disposal methods available. Methods addressed should include storing, dismantling, reusing, recycling, reprocessing, and destroying end products, enabling systems, system elements, and materials. Disposal analyses include consideration of costs, disposal sites, environmental impacts, health and safety issues, responsible agencies handling and shipping, supporting items, and applicable federal, state, local, and host nation regulations. Disposal analysis supports selection of system elements and materials that will be used in the system design and should be readdressed to consider design and project impacts from changing laws and regulations throughout the project lifecycle. Disposal strategy and design considerations are updated throughout the system lifecycle in response to changes in applicable laws, regulations, and policy. Consider donating an obsolete system. Many items, both systems and information of cultural and historical value, have been lost to posterity because museums and conservations were not considered as an option during the retirement stage. Concepts such as zero footprint and zero emissions drive current trends toward corporate social responsibility that influence decision making regarding cleaner production and operational environments and eventual disposal of depleted materials and systems. The ISO 14000 series includes standards for environmental management systems and life cycle assessment. Instead of designing cradle to grave products dumped in landfills at the end of their life, a new concept is transforming industry by creating products for cradle to cradle cycles whose materials are perpetually circulated in closed loops. Maintaining materials in closed loops maximizes materials value without damaging ecosystems.